Okay. Over to you, Prashant.
Hey, so welcome everyone to this UGPN webinar. So the UGPN, that stands for University Global Partnership Network. So this is basically a network between the University of Surrey, University of São Paulo, and the North Carolina State University. So we got two speakers today, and they will be talking about the work which has been going on as part of a joint project, which I'll introduce briefly. So usually, there were a couple of this in this series. We had around 4 to 6 webinars. So this is the second last one, and the last one is going to be in May. So usually these webinars are on Wednesday, 4 to 5 p.m. So we got 2 speakers today. So we in the last one, you could see that we had 2 fantastic speakers, and this one, and they both basically speak for around 20 minutes. These webinars are recorded, so you could watch them later on our YouTube channel. So we'll send you the post the link in the chat box. So just to introduce very briefly this project. So this project is called UGPN NBS, which is Prescription of Nature-Based Solutions to Cities. So this project is a collaborative work between the University of Surrey, University of São Paulo, and North Carolina State University. But it also have a big network of people, around 45 members, which come from Brazil, UK, China, and Australia. The whole focus of this, the project is to build an international network in the nature-based solutions area, and advancing the nature-based, the solutions to mitigate environmental challenges. So we have been using some of those approaches, like the AI monitoring, modeling, and citizen science. So you'll hear on 2 projects which are linked to this particular project from our speakers today. And the whole idea of the project has been to establish this global network, create some case studies that is tailored prescription for cities like Sao Paulo, Raleigh, and Guildford, and then facilitate the knowledge exchange through staff and mobility, and obviously working on the ideas to produce joint publications and the the joint funding opportunities. So today we got 2 speakers. So the first one is Dr. Mario Gavidia-Calderon. Sorry if I did not pronounce your name well. So Mario obtained his PhD in meteorology from University of São Paulo in 2020. And in 2015, he concluded his master's in meteorology at the same university, and his research is focused on multi-scale air quality modeling and data analysis. He's involved in the open source development by building packages and scripts using R and Python. And today he will be talking about the heat waves and air pollution in metropolitan area of Sao Paulo. Before I hand over to Mario, so just a few housekeeping notes. Firstly, we have this webinar is being recorded, so that we can make it available later on. Secondly, if you have any questions, so please use Q&A box, which you can see on your screen. Write your name and affiliation and the question, so I can read it out to our speakers today. And then, so what we're going to do is we will have our speakers one after another, each speaking for 20 minutes. And then I will read out your questions to our speakers once they have finished their presentations. So without any further ado, so welcome, Mario, and thank you for for giving us the opportunity to listen to you. So over to you.
Okay. Can you see my screen?
Yes.
Perfect. Good morning, good afternoon, good evening to everybody. Thank you for the invitation. Today I'm going to talk about heat waves and air pollution in the metropolitan area of Sao Paulo. Right? How this idea came, right? You may realize that I'm not Brazilian. I'm actually from Peru, but I've been living here for almost 11 years. And in the last couple of years, I suffered the very intense heat waves here. You know, in Sao Paulo, there are these clocks are installed around the city that show us the time, the temperature, and the air quality. And in this picture, you can see a red square that says that at 11:24, we have a really bad air quality in Sao Paulo, right? And when I was looking these clocks, I also see a temperature, and so I asked to myself, right, how worse the air quality is during heat waves in Sao Paulo, right? So that was my personal motivation, right? But when we look at the big picture, we see at least that the work that focus on the effects of heat waves here in Sao Paulo or in South America are mainly focused on the thermal stress. For example, and also that focus also is from the municipalities, right? Our institution, right? For example, here in the right side, you can see an alert, a notification that come to your cell phone that say that, hey, it's actually this message is from today. We will have a higher temperature. Please be careful for the heat, warmer and drier condition, right? So nobody says anything about the air pollution, right? And it seems that maybe the health impact that were calculated based on the effect of the heat waves is underpredicted because it doesn't account for the effect of the air pollution, right? Therefore, the main objective of this work is like to characterize the air quality during the heat waves, right? But first, what is a heat wave, right? There are many definitions in the bibliography, right? There is a definition from the IPCC, another from the International Meteorology vocabulary. When you look for that in books of oral meteorology, also there are many definitions, but there are some keywords that are repeated, right? We have, for example, hot, warm, threshold, many days, continuous days, right? So in this guideline that was published by the WMO, they summarized all these definitions and say that, hey, a heat wave is a situation with a period of marked and unusually hot weather persistent for at least 2 consecutive days, right? But this definition has some nuances. For example, unusually hot weather is different in Guilford, and it's different in Sao Paulo and in Raleigh, right? And when you look for the publications, they usually consider 3 consecutive days of this situation as a heat wave, right? So that's something to take into consideration, right? But before jump to the methodology and results, this is a parenthesis, like what are the ingredients to cook a high pollution episode, right? What are the meteorological factors that impact or that produce a high pollution episode? Yeah? We have clear skies, if we have high radiation, if we have high temperatures, lower winds, and lower planetary boundary layer height, and together with high emissions, we will have a high pollution episode, right? And because we are focusing on the metropolitan area of Sao Paulo, which is the largest urban area here in South America, the high emission is a fact, right? And you can see here a picture from my window, right? The smoke formed during heat waves in Sao Paulo, right? So, methodology. The data come from the meteorological data come from an automatic weather station called Mirante that is located inside the city. You can see here the red X that marks the location of the Mirante automatic weather station. We also using data from the CETES air quality network that this is the environmental agency of the state of Sao Paulo that have many air quality stations installed around the metropolitan area of Sao Paulo. And what we do was identify the day with heat waves and compare with the situation of the days with no heat waves, right? How we define this day with heat wave, right? Well, we use 3 consecutive days with the maximum temperature higher than the 90th percentile, right? We choose 3 consecutive days because that was the criteria used in the work in Song and collaborator for China, and also in the work of Valverde and collaborator that it was focused on the synoptic condition of Sao Paulo, right? We also discard the days with diurnal precipitation above 2 millimeters, and we will focus mainly on PM2.5 and ozone because these are the pollutants that usually surpass the air quality standard and air quality guidelines levels, right? With that, we have that from our study period that goes from 2018 to 2023. We have that the 90th percentile of maximum temperature is almost 32 degrees. With that, we identified 28 heat waves events that account for 108 days of heat waves. Right. So some results. This is a summary of the heat wave events, right? On average, we have almost 5 heat waves per year, right? The duration of the number of days with heat waves varies between years, right? But what we have to look is for in what month the heat waves happen, right? In many works, usually they say that in different settings that the heat wave happen in summer, right? Here in Sao Paulo, most of the heat waves happen during spring. The springs here in Sao Paulo go from September to November, right? And the summer go from December to February. And something that also worries me is that in the last year, in 2021 and 2023, we found heat waves at the end of the winter, yes, August, and also in the beginning of the fall, right? In March, right? And maybe it shows some of the effect of the climate change that we are suffering, right? On the other hand, something that also worries me is that there are heat wave events that can last for more than 5 consecutive days, right? So you can imagine the exposition, right? Exposition to higher temperatures together with exposition to high pollutant concentration, right? So the meteorology, right? We can see clearly that during heat wave we have higher temperature, we have drier conditions, we have lower winds. Here we have lower wind during nighttime, and also we have a high radiation, right? And if you remember our recipe for a high pollutant event, we have all the ingredients, right? We have clear skies because we have high radiation. Also, we have high radiation that enhance the photochemistry of the atmospheres. We have high temperature that is related to ozone concentration, but also higher concentration produce more evaporative VOC, volatile organic compounds emissions, right? From both anthropogenic and biogenic. Also, when we have drier conditions, we reduce our wet deposition, right? And when we have lower winds, we have less dispersions of pollutants. And because this happens really during the night, we have that the precursors of ozone and PM2.5 that form during the day is not dispersed during the night and enter during the day, right? That produce higher concentration, right? As a matter of fact, I just remembered that the highest temperature recorded here during the heat wave was almost 38 degrees. Yes. What about the pollutant concentration, right? we have high ozone and high particulate aerosol, right? Particulate matter, PM2.5. If we see, we have almost the hourly ozone concentration increasing 55%, and the hourly PM2.5 concentration increase in 44% during the heat wave, right? The ozone is formed because we have more VOCs, and Sao Paulo is a VOC limited environment. We have more VOC emission, right? And higher radiation, right? So we will have, ozone will be formed really easy, right? Also, why we have higher PM2.5, also we have lower winds, so it not disperse the PM2.5. And also, we're trying to figure out, to determine the influence of the secondary organic formation, right, of aerosols. And here I'm showing you some concentration of two anthropogenic VOC, toluene and benzene. Toluene is really dependent on temperature. And we can see that during the night we have higher concentration, and during the day lower, right? I think that the lower concentration of toluene during the day is caused because it's consumed to form ozone. And when we see the situation in all the air quality station, and when we use two parameters that determine their quality, right, like the maximum daily average, maximum daily 8-hour average of ozone and the daily average of 2.5, we can see that the situation happens in all the city. It's not that in some station we will have lower concentration during the heat waves. No, it happens in all the city. And when we evaluate the MD8 of ozone, right, we can see that it surpassed both the air quality standard of Sao Paulo and also from the World Health Organization, right? We go from almost to 100 micrograms per cubic meter. We can reach even 175 micrograms per cubic meters of MD8 ozone, right? And when we see the PM2.5, also we see that the increased ozone is high during heat waves. If we use the criteria of the WHO, we have a bad situation of PM2.5, but during the heat wave it's really worse. Yes. So these parameters almost increasing at 45-42% during the heat waves. Well, final remarks, right? Well, we see that heat wave produce favorable conditions for high pollutant episodes. In Sao Paulo, the heat wave happens mainly in springs, also happening in summer, but mainly in spring. During heat wave, we will have an increase and surpass of the air quality standard of ozone MD8, and also we will have PM2.5 daily average that also increase, right, to over the WHO standard, right? And we believe that these results show us that when we try to assess the impact of heat wave, we should also look at for the effects of air pollutions. And this reminds me also the situation about the climate penalty, right? The IPCC said that climate penalty refers to the condition where even when you decrease the emission, you will have a pollution episode caused by the increase of temperature, right? And also in the context of climate change, we will have extreme weather more frequent and more intense, right? So it's something that we need to keep in mind. Currently, I'm trying to add the data from 2024 to the analysis, and also because we are covering many years periods, in the university there were some campaigns of particle numbers measurement and also isoprene measurement that I think could give us more information to characterize the air quality, the air pollution during heat waves, right? And that's it. Thank you for your time and invitation. Obrigado.
Perfect. Yeah. Thank you. Thank you very much, Mario. It's very helpful and very nicely presented. I like your figures, very clear. That tells the story by themselves. So without any further ado, I'm gonna introduce to our next speaker. So next speaker is Soheila Khalili. So she's a PhD student at the Global Center for Clean Air Research at the University of Surrey, which is sitting in the Civil and Engineering Department. And she's researching the effects of green infrastructure on urban heating and air quality. She holds a master's degree in architecture and energy and a bachelor's degree in civil engineering. She's a chartered engineer and architect in Iran. She worked for several years as a designer in consultancy firm, focusing on energy efficient building design before pursuing her doctoral studies. Her research focusing on sustainable urban development, integrating engineering and environmental challenges to improve urban resilience, mitigate heat stress, and enhance air quality. She's going to present her work on some of the case study which we generated recently in Guildford as part of this work. Without any further ado, over to you, Soheila.
Can you see my screen now?
Yes.
Hello everyone, my name is Soheila Khalili. I'm a PhD student at the Global Center for Clean Air Research. Today I will be presenting part of the results from one of my monitoring projects I conducted for my PhD. This presentation focuses on quantifying the co-benefits of urban park, specifically in terms of heat mitigation, thermal comfort, and air pollution. To provide a brief introduction to this topic, the rapid pace of urbanization in recent years has led to numerous environmental challenges in urban areas, such as rising temperature, air pollution, reduced thermal comfort conditions, noise pollution, and many other environmental challenges. Green infrastructure, such as green walls, green roofs, parks, woodlands, and hedges, street trees, and many other types are effective strategies for mitigating the harmful impacts of climate change and provides a wide range of ecosystem services. For this study, we focused on evaluating the co-benefits of a specific GI type, which is an urban park, in terms of heat mitigation, thermal comfort, and air pollution, to evaluate the gradient and extent of these benefits provided by the park. For this study, Stoke Park was selected as a case study, which is located in Guildford town area. And the mobile monitoring was conducted for 10 days during summer months in August and September 2023. As it can be seen in this figure, the white cross on the left side was the start point. It was like mobile monitoring walking through this paths in park area and then moving to surrounding built-up area, which can be seen as a red shaded rectangle, and then doing this again for 5 different routes. This field campaign, this monitoring data collection was done 3 times per day in morning from 8 a.m. to 9 a.m. to capture the peak air pollutant levels in the morning, and the second run was from 12:30 to 1:30 to capture the afternoon peak when the highest temperature occurs, and the third run was done from 5 to 6 p.m. To capture the evening peak pollutant levels. As I said, this was done for 10 days, 3 times each day. So it was in total 30 rounds. In this data collection, air temperature, black globe temperature, wind speed, relative humidity, and CO2 were measured using a Testo 400 device. And also PM values were measured using Green 11D. And also a GPS was used to map the location. As well as doing this mobile monitoring, there were 3 locations which can be seen as white circles on the figure, showing number 1, 2, and 3. These locations were like fixed monitoring locations for 5 minutes. The first one is located in a tree-shaded area. The second one is in grassland, and the third one is in built-up area, to compare the thermal comfort conditions in these 3 different locations. The results of this monitoring show that there is noticeable difference between pollutant and air temperature levels inside the park and urban area compared to urban area, as it can be seen for air temperature. As it can be seen for air temperature, the temperature was relatively lower in during all periods in morning, afternoon, and evening. Especially in the afternoon run, it can be seen that the difference between air temperature inside the park and built-up area was around 2.4 degrees Celsius, which means 8.9% reduction offered by the park. As for relative humidity, the relative humidity was higher inside the park because of the vegetation and humidity causing by the vegetation. It can be seen in the afternoon. The relative humidity was higher in the park by 3.1%. For CO2, this value was lower in the park, especially in the morning and afternoon. But in the evening, the difference between park and built-up area was very low. There was not that much difference between these areas. As for PM values, the PM values were relatively lower in park, especially in the morning and evening when the peak traffic was occurring. I think the numbers are not showing on this slide. I don't know what the issue is, but the difference was between 7% up to 13% in the morning and evening, but in the afternoon runs, the difference was lower because there was not that much traffic. But in the peak traffic times, the difference between park and built-up area was noticeable. That was because the park was reducing these parameters and acting as a barrier to not let the pollutants to get inside the park. Yeah, it can be seen here. The PM values in the morning was 30.3% lower inside the park. In the next step, we tried to see the spatial distribution of temperature and PM values inside the park and urban area. As it can be seen in the air temperature map, the air temperature was higher in the built-up area, and as we get deeper into the park, the temperature decreased. Same for the PM10 values in the built-up area. The PM10 values were higher, also in close to the road. But as we can see, as we get deeper into the park, especially in the center of the park, the PM10 levels were lower. For PM 2.5 and PM1, the same thing happened. We can see that in the center of the park, these values are lower compared to the built-up area and surrounding roads. So it can be concluded that by getting away from the built-up area towards the park, the temperature and pollutant levels dropped significantly. In the next step, I tried to see how the temperature is changing by getting far from center of the park. It can be seen in this figure that y-axis is the distance from the center of the park. So 0 means center of the park moving to 400 meters. It can be seen that in the morning, the blue lines are representing park and the red lines are representing build. As the data was collected per second, and I had a lot of noisy data, so moving average method was used to reduce the noise and see the trend. After applying this method, I've seen that by getting away from the park, the temperature is increasing. Especially in the afternoon run, we can see a sharp trend happening in built-up area, while the trend for the park is not that much sharp. In the evening, we can see that the temperature was even decreasing somehow. This was also confirmed by many previous studies showing that in the evening and during the night, the temperature inside the park might be higher compared to the built-up area. This happens because of shading and heat trap and many other factors affecting the temperature. In the right figure, it can be seen the temporal variation of temperature. This is just for one day when the peak temperature occurred during the afternoon. We had the highest temperature on this day, which was 4th of April. We can see in this figure, P shows park and built represents built-up area. We can see that by walking from park to built-up area, the temperature increases, while moving from built-up area to the park, the temperature starts to decrease. So their temperature increases in the morning and afternoon by getting away from the park center. In the next step, I assessed the thermal comfort condition in 3 different locations inside in this case study. 2 were inside the park, which first one was tree shaded area, which is represented by green color. The second one was grassland. It was in the park, representing by blue color, and the third one was the built-up area. The aim was to compare how the thermal comfort conditions are different in these 3 sites. For this purpose, I used 2 different thermal comfort indices. The first one is physiological equivalent temperature, and the second one is universal thermal climate index. These 2 thermal comfort indices are most widely used thermal comfort indices for outdoor environment. For PET, when PET is between 18 to 23, it can be considered as a comfort range. So we can see in the first figure that during morning and afternoon time, most of all 3 locations were almost in the comfort range, except the tree shaded area in the morning, which falls into a slightly cool. But in the afternoon, we can see that the built-up area is falling in the warm range, when tree shaded area is still in comfort range, and the grassland is in a slightly warm range, close to comfort range. And also for UTCI, it can be seen that between 9 and 26 degree UTCI can be considered as no thermal stress range. And in morning and evening, we can see that all 3 locations falls in this no thermal stress range, while in the afternoon, the built-up area was experiencing moderate heat stress, even with some points reaching to strong heat stress, while the grassland was totally in no thermal stress, and the tree shaded area was close to no thermal stress, with some points reaching in moderate heat stress. So it can be concluded that the thermal comfort conditions inside the park and in the tree shaded area and grassland, both of them, were close to comfort range, while for the built-up area in the afternoon, it was close to warm and moderate heat stress conditions, and people standing in those areas were experiencing warm thermal comfort conditions. And finally, to conclude, there are several co-benefits provided by green infrastructure. In this study, I focus on heat mitigation, air pollution, and thermal comfort, and it can be seen that the air temperature were consistently lower in the park, with reaching 2.4 degrees Celsius, which is 8.9% reduction in air temperature in the afternoon when the highest temperature occurs. And for PM values, the PM values in the park were consistently lower in the park during all periods. The morning reduction and after evening reduction reached up to 13%, and in the afternoon it was up to 8%. As for CO2 values were lower in the park, with reductions of around 4% in the morning and afternoon, with not much difference in the evening compared to the built-up area. And for thermal comfort, the two locations, which were tree shaded area and grassland inside the park, significantly improved thermal comfort, with thermal comfort indices values within or close to the comfort range, while the built-up area was experiencing warm and moderate heat stress during the afternoon peak based on PET and UTCI classification. These are three environmental benefits offered by park. There are so many social, economical, and recreational, and many other benefits provided by urban parks and all other GI types. Having insights about how green infrastructure is improving the condition in urban areas can help city planners and people to have livable cities and design more sustainable cities. Thank you for your time.
Perfect. Yeah, thank you very much to both of you. Excellent presentations, very nicely presented slides, clear figures, and well on time. So well done to both of you. Could we have any questions for our speakers? So can see a few questions here. So first one is for Mario. So the question is from Jeet, and he's asking, heat waves coincides with air pollution events. Is this, how does this happen? What could be the reason and possible mitigation? It is only advisable at the time just to stay home and don't go outside, or you could do something. So a couple of questions in one question.
Well, there are also high pollution episodes when there is no heat waves, right? But usually when we have heat wave, we will have higher concentration. Sometimes there will be over the quality standard, or sometimes they are close to that, right? But so my point is that not always when we have heat wave, we will have a high pollution episode. There is high, I need to calculate that percentage, by the way. But there are also high pollutant episodes that happen when there is no heat wave, right? That could be, for example, when we have here biomass burning months, right? So, and then we will have a heat wave, a high pollution episode, right? About the measurements, I really don't know so much, but I was imagining that maybe if you have to work outside during the heat wave, maybe use a mask. I imagine, right? But at least during heat wave, please don't do sports. Don't run on, or you can run inside parks, right?
Okay, good.
Thank you for your question.
Yeah. So I believe that, I mean, there is, it's not that because the heat waves are bringing the air pollution episodes, it's just that there are different sources.
Yeah.
But obviously the photochemistry could be different during the heat wave, so that could possibly make things worse.
That's true.
Because of certain conditions, but it's not that necessary that heat waves must bring the pollution episodes or other way around, right? So,
yeah, that's right. Yeah, I think that's the word. It enhances, it worsens air pollution.
worsen, yeah. So the compounds the impact on the health.
Yes.
So you're suffering with two things at a time: the heat impact as well as the pollution impact. Okay, we got another question for Soheila. So that's also from Ajit. Would you be interesting to see combined effect, distance from center of park, and second one could be shortest distance from the nearby urban area, to see the effect of urban area also for cooling on a particular point. So can we get a rate of cooling degrees Celsius per meter as a function of distance away from or close to the center of park or urban area? Did you understand the question? Mute.
Sorry. Yes, we can get this rate. We already have the trend line, so the rate can be easily derived from that. But because this was done through monitoring and walking, the distance was not that much high, but I've seen many papers doing this using satellite data. The trend is not like a line, it changes by distance. So when getting away from the park up to some meters or kilometers, the trend is like a line, but after that it starts dropping. So the rate is not consistent, but for this study we can consider it as a line because the distance is not that much high and the rate can be calculated based on the trend line we already have.
Yeah, so if I could say something, actually, the trend line you put it in is already giving you the rate. So you see the slope. The slope is the rate basically. So ideally, you have that rate already available. That rate is increasing during the morning and in the afternoons. I could see that. And then it's decreasing basically during the evening because it's on the peak in the midday. And then when you go towards the end of the day, then it's getting cooler. So, so honestly, you got already those rates, what is being asked there.
Yeah.
Okay. So got another question from Akash for Mario. Why is the PM 2.5 concentrations are similar magnitude during the evening and night? The role of PBLH is not clear, or the HW and NSW days are from the same month.
That's a good question, but I think that I think in my figure it's I need to adjust maybe the epsilon, the y-axis, because it's different. It has some. It actually has some variation, right, during the night and during the day. Usually, what happens here in Sao Paulo is that during the traffic peaks hour, you will have higher concentration of PM 2.5. Sometimes you will have a high concentration of PM 2.5 in the night by formation of secondary organic aerosol, but nitrate, for example. But usually, and also you will have difference variation in PM 2.5 in spring, but you also have a contribution for biomass burning emissions, right? But here, at least the concentration from the heat waves comes from concentration from September to March. That are the period that we usually have heat wave here in Sao Paulo, right? But that's a good observation. I need to redo that figure because there is some variation during the night and during the day. Yeah.
Okay. Perfect. Yeah. So got another question for Soheila, and that's from Akash as well. He's asking, some point locations in the park have similar magnitude of the built-up area for PM 2.5 in the spatial map. What could be the reason?
For the PM 2.5, as it was seen in the map, there was a road on the north side of the park and also on the south side of the park. So the pollutants were penetrating the park from both sides, and the first 10 meters, 20 meters of parks, we can see that the PM values are there. But when we get deeper into the park, close to the center of the park, the values were decreasing. But on the edge of the park, the pollutant level was almost similar to built-up area because of the road which was located between the park and built-up area.
Okay. Anyone have any more questions? Otherwise, I'm going to ask you a question. I mean, did you look into the what are the predominant wind directions during the monitoring period? Well, that could explain actually some of those PM 2.5 variations as well.
Yes, definitely. I can't remember what was the direction at that time, but I can look into it and check how it's affecting the pollutant levels.
Yeah, since you're talking about the roads on both sides, so that will kind of establish whether those roads have a direct influence in terms of transporting or the emissions actually from the roads towards the park side. Because there's no other source actually there. It's just that the traffic emissions in that particular area.
Yeah.
So it will be interesting to kind of explore that.
Yeah, I will look into that. Yeah.
Okay, good. So Mario, just ask one last question from you. So there's nothing in here. What is the one unusual finding actually you have from the work you presented today? So we all know that during the midday the temperature is going to be high. It cools down. The emissions depends actually. Sometimes there might be episodes of these things. So what is it which you found was a little bit unusual than an interesting finding?
Yeah, that's also a good question, right? Well, I was there are two things that caught my attention. The first one is that there is no work that evaluate the impact of pollution and heat wave here in South America. None of them. Mm-hmm. The other thing is that most also focus on ozone. So you have, if they consider the impact of heat waves and air pollution, they mainly focus on ozone. But what happened here in Sao Paulo is that we also have a problem with PM 2.5 during heat wave. It's not only ozone. And the other different thing is that when in other cities like in China, right, countries in China, the heat wave happens in summer. Here in Sao Paulo, happens during springs most often. So there's some that novelty, right? That we are using. We're considered more pollutants that also are harmful for the health, and this could be the one of the first work that studied the impact of air pollution in South America together with heat wave, right? And also we're trying to include measurement from other campaigns, so it will help us to characterize more what's happening in the atmosphere, right? For example, I just already got the data from particle numbers, and we have the particle numbers between heat waves and not heat wave periods, and there is a change in the mode, for example, of the aerosol, right? That's something that we don't have, and also we're trying to also include the measurements from isoprene that will give us the behavior of the biogenic emissions, right, in the photochemical formation, right? So that's it. We were trying to characterize more what happened during the heat waves. Yeah. And another thing also that I was talking with some friend, it was that in the context of climate change, where it's supposed to have more extreme events. So I believe that it's important to study more those extreme events, right?
Okay, perfect. Yeah, thank you. So one question for you, Soheila. So if you just ask actually, what are the 1 or 2 key take-home messages from the whole analysis you did as part of this study?
So definitely it would be how about how the park is improving the environmental condition. It was quite interesting for me to see how the temperature was changing in the evening. So I was expecting that this trend is happening all the time, but it was not like this. The afternoon trend line was much different, and I think that yeah, and same for pollutant levels. It was quite interesting that how it's improving the pollutants during the peak time. While at some points I've seen that the pollutants has penetrated the park, and we also had some locations that the pollutants was somehow trapped on those areas, especially close to the hedges. Yeah, and I think the most important thing is that we need some the green infrastructure should be well designed, otherwise it may somehow increase some pollutants at some point, and also temperature in sometimes. So the design, it should not be like the green infrastructure will definitely help to reduce the harmful effects of climate change. It should be well designed and well studied.
Okay, perfect. So I think I will possibly like to close it here, these discussions. And but before we do that, then we'd like to thank both our fantastic speakers today, both of our ECRs, young researchers, and we might want to give them a big round of applause for their fantastic presentation. So just to introduce to the next webinar, so we got another 2 young researchers. So one is finishing up her PhD from Sao Paulo, University of Sao Paulo, Leticia. So she will be talking about the deployment of environmental education to uplift community in an urban heat island. And then we got the another speaker, Dr. Jitendra Sahani from our team, GCARE team, and he will be talking about the enhancing school climate resilience through green-blue gray infrastructure, experiential and co-design learning. So these are interesting presentations coming up for you next month. So please keep the date in your diaries. And yeah, we will look forward to see you next week. Next month. And have a nice Easter break in between. So thank you very much, everyone. Bye.
Thank you. Bye-bye. Take care.
Thank you. Bye.